Hey everybody, this is Larry. This is day 18th. Wow. It's been 18 days in July. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Today's problem is LRU cache, least recently used. This is a pretty standard problem. I probably have done this 3 or 4 times even on Leetcode. 3 times. I think I got it wrong a few times. Oops. Hopefully this time I'll get it right. I would say even personal. This used to be a very popular interview problem, and even I have gotten it like personally, gotten it a few times in the past. So yeah. So definitely, I don't know. I maybe nowadays it's too easy, but or no, I don't know if it's easy in the sense that like it's conceptually easier. I mean, the problem has been the same problem, but it's just that people know about it long enough to practice it know enough so that it's in that way it is easier in the sense or that more people are able to solve it, so it's easier in that sense. But it is what it is. So let's I forgot what it is though, to be honest. So let's see if I can remember it. Okay, so LRU is least recently used. So you have a get, which gets the value of key, put, which updates the value of put, and also yeah, obviously add it to the cache. If the number of keys exceed the capacity from this operation, you rect the least recently used key. The function get and put must each be over 1 average. Yeah. So okay, yeah. So yeah. So the way that I would do it is with a linked list. Yeah, I'm trying to think what it is. Oh man, I also just took a nap, so I just woke up. But but you can maybe even do it without the linked list. But the But yeah, basically the idea about using a linked list is that you have over one access to finding the or you have a lookup table to look it up, but you can also have an order. You can maintain that order list in all of one time. Where if you have like if you do it with a generic that or like a tree data structure, it'll be log n, right? So that's basically the idea, really, because you can add and remove things in all at one time if you have access to them. Yeah, I don't know. I don't know if there's a. I think that's all I have for this one, in terms of setup. I think there are a couple of ways you can do. I mean, I'm trying to think whether I need it or it's been a while, I suppose. I think I'm going to do it with a doubly linked list, but you can think. I mean, I was just trying to think for a quick second whether I can do this with. Yeah, with a singly linked list. So I was typing and then I got confused or talking at the same time. Today I'm really like off, I suppose. But yeah, just have something like this, right? It's just a very basic thing. So then now we have maybe self.head is equal to the node of like -1. I don't know if -1 is a valid value. So just trying. Yep. Okay. That's the key. All right. and maybe just a lookup table for the lookup, and then we just use this. Can just be a regular hash table, right? And then self dot, oh, and we have to keep track of the capacity. I don't know why I'm so slow today. I'm pretty sluggish. The heat has been really bothering me a little bit. I don't know why this year more than usual, to be honest. Or maybe I'm just complaining more. I don't know. Maybe I'm also older. But anyway, yeah. So if key is in self.lookup, then we turn self.lookup, I think. But I forget. I have to kind of, I think that this is something that maybe I complained about this last time. I really have some memory about complaining about this, but I don't know what least recently used means. Like, is it just the put or is it the get? I mean, like, I could probably guess, but you know, that's the thing with a spec, is that they usually should tell you more specifically. And I don't know why that they don't tell you. Least recently, okay. So it seems like with this example, the get of 1 returns the thing. So okay, so then we have to do something more than that. But yeah, if this is not in self.lookup, we return -1. Otherwise, we return it, but we should update this to how do I say? Update it to mark this as the latest recently used, last recently used, most recently used. Is it? I don't know. English is hard, right? So here, I didn't really explain this. Sorry, friends. I'm a little bit. It's kind of, I don't know why I'm a little bit off today on the English and everything. But basically, the idea is that okay, we have a linked list, we have a head and a tail, and you could, you know. These are just my current conventions. You can do it whichever way you want, and you know, it doesn't really matter as long as you're consistent and explain it. And the idea behind an ADT, an abstract data type, is that implementation doesn't matter as long as you guarantee complexity and runtime and performance for each function, right? Or each method, I suppose. So yeah, but to explain how I'm doing it, the head of it is going to be the least recently used, and then the tail is going to be the most recently used, so that anytime we use something, and this is where I want to make sure that I get that definition correct, I move it to the end. So that when we need to erect, we get stuff from the head. So that's the idea. Yeah. So yeah, so here, to show that this is used, we want to find it and then move it to the end. I didn't really do a good job here, did I? I think okay. Lookup is a terrible word name. Maybe, and then maybe something like position or something like this. Also another hash table, but this will hash to the node. So yeah, so self.position of key, right? So this is the node that so this is the node, and this is the node that we want to move to the end. So that means that node.previous is equal to node node.previous.next. I don't know what I just did. Anyway, okay. Sorry, technical difficulties. Node.previous.next is equal to node.next. Node.next.previous is equal to node.previous. So this just basically, you know, makes it so that it essentially delete this node. Delete this node, right? And then move to the end. So then self.tail.next is equal to node, and node.previous is equal to self.tail, and node.next is equal to none. And I think that should be good, right? And then put is the same thing. I mean, we just have to follow the rules that they give us. So if key is, and maybe here we can yeah, maybe we'll abstract this to a helper, but for now, let's, if node is not in lookup, what does that mean? What if it is in lookup? If it's in lookup, then we update it. How do I want to say it precisely? So I think it doesn't matter, right? So I think it just means that if it is non-lookup, then we create a new one, right? So self.lookup is equal to, of key is equal to value, and self.position, is it? Position of key is equal to a new node with the value, and then self.position of key dot preview, and then this is just adding it to the end, right? Oh, I have to update tail. I messed this up previously. Okay, so let's just do it this way. Okay. But we also have to do self.tail is equal to node. Yeah, because this is now the new tail. Is this true? Huh. Maybe I did it wrong for a doubly linked list. Let me think about this for a second. So, yeah, I think I did this wrong for a doubly linked list because I still wanted to keep the sentinel. So the put this at the end is wrong, and this is why you want to dry, so that you don't have to do this code duplication thing. So you only have to do it once. But I got confused. All right, so put this at the end. Self dot. Okay, how do we want to do it at the end, right? So self dot tail dot previous dot. Wait, what? What am I doing? Okay. So the tail's previous next is equal to this node. Node dot next is equal to tail, and then node dot previous is equal to self dot tail dot previous or something like this, right? Wait, let me see. Yeah, so this is true, this is true. Maybe this is not yet. Okay, so this is a new node. We set the next, and then we set the previous, and then we set self.tail.previous is equal to node, right? Yeah. And then node.previous.next is equal to node. Yeah. And technically, this is node.next.previous. Yeah, just for the symmetry. Even though it is the same thing. Man, I am like really bad at programming today. Sorry that y'all have to watch for this. And yeah, like I said, this is some copy and paste thing. I usually don't do it this way. That's why I'm kind of have to retrace my things. Linked list has been my weak point. So yeah. Okay, so if this is not, am I done? If this is not, I mean, if I think this is done, right? With respect to if the key is not in the list. If the key is in the list, then we have to update it. So then, oh sorry, we're not done because I have to check for the length of the thing. So yeah, so this is an update. We have to find node is equal to self dot lookup position of key, and then we have to update this node. Okay, fine. So let's just say I have update node or node update maybe. Put this node at the end, right? So right. And maybe put this. Okay, whatever. Right, and then now we can do self.node update of node. And this one as well, though we have to check for, it just means we have to check for, yeah, if node.previous is not none, not a new node. Yeah. Okay, yeah, and then here we also do a node update, hopefully. Wow, like I feel like you should, I don't know how you should do this, but man, today feels a little bit sadder. Okay, but yeah, so now we basically say no matter what, we move this node to the end, and we can, you know, you can also see some similarity. And then maybe like and then just like quick refactor, or maybe something like if key is implicit. Right? So something like this, right? So then now we kind of dry ourselves, refactoring the code so we got rid of code duplication. Okay, so then now this is basically saying that, okay, no matter what, we create a node or update it and we move it to the end. Okay. Oh, this is wrong. There we go. Okay, and then now we have to check if it goes over, right? So if length of self.lookup, and you can maybe put this in whatever, self.capacity, then, and maybe we could even put in a while loop just for fun. We can direct from the head, right? So then now we just do, actually I kind of made it more confusing because the node has a value. But the value is actually the key in the lookup, so so in my mind it's fine. But I just noticed that it could be confusing for people who are just looking at this in a non-isolated way. But yeah, so basically, what am I doing again? Oh, we move from the head. So self.head.next. So the node is going to be equal to this thing that we're erecting, and basically how are we erecting it? We do self.hex. Head.next is equal to node.next, and then yeah, and then node.next.previous is equal to self.head, right? I feel like I'm missing some stuff. I'm missing some stuff because we never connect head and tail, so I think that's where, well, we never connect anything to head, but I think what I have to do is that self.head.next is self.tail, self.tail.previous is equal to self.head, and I think maybe we're good, but I feel like I'm missing some cases with where this is going to pop up with nuns. And that's going to be a mess. We'll see. We'll have to just test good / give some wrong answers. Today I'm really poor. But yeah, so node.next.previous is equal to self.head. Yeah, and then now node.value is the key we want to erect. So we want to delete this and the position lookup. And I think that should be good. Do we just put return anything? No? Okay. Yeah, that's why I thought. But let's keep it running real quick. I thought we assigned it. Oh, I lied. Oh, that's why I had node is equal to Okay. Well, this is not really that good of a test case, or it's only one test case, but mostly I'm just lazy. We could come up with some stuff, so let's just kind of give it a quick submit. Okay. So yeah, that's what test case is that? Number 4. That's a little bit embarrassing. Maybe not. I don't know. Okay, let's look through this case. I feel like I am sloppy on this one. I was very low confident on this, but yeah. So put 1 0. How can this not be true? Did I mess something up? We already looked up them. Oh, did I put in the wrong thing? I might put in the wrong thing. For new node. Oh yeah, see, because here it should be key. It's kind of funny because I was talking about this. Yeah, I was talking about how I was literally just talking about it, and then I messed that up. I was like, oh yeah, it is confusing because the key and the value, blah 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 blah, and then I messed it up. So that proves to, I don't know. It happens, I suppose. Ah, so other than that, actually, so my only mistake was actually saying the thing that I was saying, which is that because the node value contains the key, and then I confused myself and put it that way anyway. So yeah. Do I think I want to go back and see whether I got it right the first time, because I did the refactor, and once I did the refactor, I don't think so. Maybe I think I got it wrong anyway. But once I did the refactor, I think I confused it definitely by then. Yeah. As usual with linked list problem, the recommendation that I always say is that if you're confused about these, just draw it out. Yeah. I think one thing that I want to point out here is just like as a minor emphasis, not too much, is that I know that many people use Sentinel values for singly linked lists. And you know, and I even for myself, I don't think I use Sentinel values for doubly linked lists that much, but you can kind of see me just working through it a little bit as I kind of go through it, and that makes it a lot easier. So yeah, this is the top, in case you're wondering. This is kind of the middle, maybe the bottom, and yeah, I'm just curious. Well, last time I did it with no wrong answers, but today it was a little bit sad. How did I do it last time? I used a sorted list. Was I just lazy? I guess so. I didn't get a wrong answer that time, but I feel like using sorted list is kind of cheating because this is like the log n way, right? And I think there's a, one amortized. How did I just like that? Was I just lazy that time? Maybe, I guess. Yeah, this time I did it with the even though I had a class of linked lists instead, so that made this code easier. But yeah, but it's very easy. As you can see, it's very easy to get wrong answers anyway. I only had one Sentinel for this one. I don't remember how to do Sentinels for doubly linked lists, maybe. But yeah, seems like I've never got a not perfect. I never got a perfect score on this one. On at least not for the linked list one. I don't know what to say about that one. Cool. That's all I have for this one. Let me know what you think. Yeah. Stay good. Stay healthy to good mental health. I'll see y'all later and take care. Bye bye.